Partition algorithm. It is an algorithm which takes in an array, chooses any of its elements and calls it the pivot, moves those elements which are less than the pivot to the left of the pivot, and moves those elements which are greater than the pivot to the right of the pivot. It places the pivot at its correct position and returns the index at which the pivot is in its correct position. So, with a sample array, let us see how this partition algorithm works. I've written down the elements of the array. Now I'm going to write down the indexes. The first step of the partition algorithm is to choose a pivot. This pivot can be chosen as any element of the array, but for convenience sake, let us choose the pivot as the last element of the array. In this case, our pivot is 4. Next, what we will do is we will have a variable called pi. Pi represents a pivot index. It is a potential index at which the pivot could be placed. Let us say the potential index at which the pivot could be placed is 0. What we mean by a potential pivot index is that the element at pi and the pivot could be swapped, and then the pivot will come to the index pi. That is how we place the pivot at the pivot index, pi. So when does this pi become the correct index at which the pivot is placed in its correct position? When all the elements that are less than the pivot come to the left of the pivot, and all the elements which are greater than the pivot come to the right of the pivot, and the pivot is placed at pi, we say that pi is the correct index of the pivot. The aim of this algorithm is to find that correct pi. So what we will do is, we will traverse the array from the 0th element up till the pivot using a counter variable, say I. We will take each element of the array and see whether it violates the condition that pi is the correct index. If it does violate that condition, then we will make some changes. So let us see when I is equal to 0. The element at I, or the element at 0, is 7. If we swap the element at pi and the pivot, that means 4 will come here and 7 will go here. The element at I, that is 7, will appear to the right of the pivot. 7 being greater than 4 will appear to the right of 4. Hence, it does not violate the condition of pi being in the correct position. So we can start to check the next element. By that I mean we can increment I. Upon incrementing I will become 1. Now we check the element at I. If we swap the element at Pi and the pivot, 4 will come here and 7 will come here. The element at I, being 1, will appear to the right of 4. 1 is lesser than 4, and yet it will appear to the right of 4. Hence, this element violates the condition that Pi is the correct index. So we must make some changes. What are the changes we will make? First, we will swap the elements at Pi and I. Upon swapping the elements of Pi and I, we will get an array which looks like this. The next change we will make is we will increment Pi by 1. Upon incrementing Pi by 1, we will get Pi equal to 1. Now that we have made these changes, we can start to check the array with the next element. So by that, we will increment I by 1. When we increment I by 1, I will be equal to 2. The element at index 2 is 3. If we swap the element at Pi and the pivot, 4 will come here. The element at I, that is 3, will appear to the right of 4. 3 is lesser than 4, and yet it will appear to the right of 4. Therefore, the condition of a correct index, that being Pi, is violated. So we must make some changes. The first change we will make is to swap Pi and I, the elements at Pi and I. Upon swapping these two elements, we will get an array which looks like this. Once we have swapped the elements at Pi and I, we have to increment Pi by 1. When we increment Pi by 1, Pi will now equal to 2. Now that we have swapped the two elements and incremented Pi, we can start checking for the next element of the array. By that, I mean we can increment I by 1. The element at I is 5. If we swap the element at Pi and the pivot, 4 will come over here. When 4 comes over there, 5, which is greater than 4, will appear to its right. Therefore, the element at I does not violate the condition that Pi is the correct index. So, we can increment I to check the next element. Upon incrementing I will equal to 4. If we swap the element at pi and the pivot, 4 will come over here. The element at I, that is 2, will appear to the right of 4. 2, even though it is less than 4, will appear to its right. Therefore, the condition of pi being the correct index will be violated. So we must make some changes. First, we have to swap the element at pi with the element at I. Upon swapping these two elements, we will get an array which looks like this. Now that we have swapped the elements at pi and the element at I, we will increment pi by 1. Upon doing so, we will get pi equal to 3. Now that we have swapped the elements and incremented pi by 1, we can check the next element of the array. That is, we can increment I by 1. If the element at pi and the pivot were to be swapped, 4 will come over here. 6, the element at I, which is greater than 4, will appear to the right of 4. So, the element at I does not violate the condition that pi is the correct position. So, we will increment I by 1. When we increment I by 1, we would have reached the pivot. So once we have reached the pivot, the step we must do is, we must swap the element at pi and I. When I reaches the pivot, it means that every element in the array does not violate the condition that pi is the correct index. Therefore, the array is now ready for pi to be swapped with the pivot. So now I will swap the element at pi with the pivot. As you can see, 4 has come to its correct position, where all the elements less than 4 appear to its left and all the elements greater than 4 appear to its right. Now, this partition algorithm will return the index of the pivot. This is how the partition algorithm will work.